More elements. We don't have enough elements yet to make a tree, so let's look at all of the elements and then focus on the ones we need. The same principles will apply. Chemical reactions occur to create chemically stable numbers of electrons around each atom. All the elements are defined by the number of protons they have, their atomic number. When neutral, they have an equal number of electrons. The number of neutrons can vary and can be found by looking up the atomic mass and subtracting the atomic number. For now, the atomic number is critical. Here are the two elements we've discussed so far, with their atomic numbers indicated. Hydrogen and helium make up period 1. Here are all the elements, with just their atomic numbers given. For the most part, we don't need all of these to make a tree. To make a tree, most of the elements needed can be found in the second row, period 2. We have hydrogen and helium in period 1. We have lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine, and neon in period 2. Every row, or period, of the periodic table has an inert element in its right column. The inert element in period 1 is helium, He. It has 2 electrons. The inert element in period 2 is neon, or Ne, and it has 10 electrons. All inert elements are stable. They do not take part in any chemical reactions. We saw that 2 H atoms combined to form H2, so that each atom could share 2 electrons like He, helium. H2 is an example of a diatomic molecule, a gas made up of 2 atoms. In nature, hydrogen atoms are never alone. In period 2, elements share electrons to get to 10 electrons, like neon. For elements near neon on the periodic table, one solution is to form diatomic gases like H2. Which are the 3 elements in period 2 closest to neon? In nature, nitrogen, oxygen, and fluorine are not found as lone atoms. One way they are found is as these diatomic molecules, N2, O2, and F2. They form a covalent bond which allows them to share electrons so that each atom effectively has 10 electrons. To break them apart, energy is needed to break the bond. Other molecules can solve the problem of getting 10 electrons even better, creating a more stable molecule. What could be combined with oxygen, O, so that it can attain 10 electrons? Remember, you can't use helium since it's inert and won't combine with anything. Discuss. Each oxygen atom has 8 electrons. Each hydrogen atom has 1 electron. So if one oxygen atom is combined with 2 hydrogen atoms, we have 10 electrons. That's very stable. This chemical equation says that 2 hydrogen atoms combine with 1 oxygen atom to form one H2O molecule. The H2O molecule is very common and has a special name, water. It's a little more complicated in that we never find oxygen alone. It's always found as O2. So what actually occurs is this. This chemical equation says that 2 H2 molecules combine with 1 O2 molecule to form 2 H2O molecules. Notice that we're not changing the number of each type of atom, just how they are combined into molecules. We start out with 4 H atoms and 2 O atoms. We end up with 4 H atoms and 2 O atoms. This is true in all of chemistry. We rearrange atoms. We don't create or destroy atoms. Fill a container with hydrogen and oxygen gas and nothing happens. That's because the bonds of the H2 molecules and the bonds of the O2 molecule have to be broken before the new bonds of the H2O molecules can be formed. This is a case of an unstable equilibrium, a rock on the very edge of a cliff. Breaking those H2 and O2 molecular bonds requires energy, which can be supplied by a flame. The flame breaks some bonds, the resulting explosion breaks the rest. Note in this video that nothing happens without the flame. All the energy you saw released in the explosion results in very strong bonds holding together a water molecule. All the energy of that explosion would have to be put back into the water molecule to break it apart. That's why if you throw water on a fire, it puts it out. Water is very stable. It is the lowest energy state of hydrogen and oxygen. In order to run this reaction backwards, you have to add energy equal to the energy released in the explosion. It's like carrying the rock back up to the top of the cliff, but that's what trees and plants need to do to grow.